Okay, well, this is a new little charger to me, one I've never seen before. It was donated by a member so I could have a look, and we're going to have a look, see how it works and see what we can do with it. This is a Rolec dumb charger. This is the faceplate, which I'm sure people who have got them have seen. We'll turn this over and you can see we have a number of lights. Now I've got this on my bench, it's sort of mounted onto a board with other things, so I sometimes do this just to make life easier to work on. We're powering it up from this quick test socket, live, neutral and our earth coming in, connected to our breaker. This is on 240 volts and our earth coming down onto our general earth system. This at the moment is powered up and there is no car connected. We have the lead here. Now something I'm going to introduce you to. This is the plug on a lead which I cut off when I wanted a tethered lead, and basically at the end of the plug I've cut a section off. Normally this plug would have this piece on, which makes it very long, and you see it's got the part to allow you to latch it in, but by cutting that off it then allows me to connect this plug into the plug, and this allows me to use my test box which I've made, which I'll be using in these tests. This basically allows me to simulate a car being switched on. It gives me a BNC connection point for my oscilloscope to connect to, and by operating these switches I can simulate the various stages of what the vehicle should be doing and any faults. It also gives me a 13 amp plug, which can be very useful for when I'm doing the gardening and I need some 240 volt power, because that's a 32 amp supply there. But anyway, we digress. Yeah, so this allows me to simulate a car on this system to see it operating, and I'll be using this to demonstrate what we're doing. Okay, we're back at the Rolec charger. You can see here I've just removed the door, just basically to push it out of the way. We have the same status light here, which we can see flashing, telling us what the status is. This is quite a basic unit. We've got our RCD for our trip. We bring our mains into a contactor. We then go out on our 6mm cable, our tethered lead here, around to the plug, the connector, and you can see I've put my plug in, and my little status box is showing a little red LED showing that it's actually working, that we've got 12 volts, and I'm connected through with the BNC cable to the oscilloscope. And looking down here on the oscilloscope we can see some measurements. It's telling us we're at 11.8 volts, so that's our 12 volt signal pilot line. We'll give our minimum value that it can see, duty cycle and our frequency, so we'll probably be looking at these in a little while. So basically to give a rundown, I will make that we've connected the car in, and I will make the connection, and we can now see on the oscilloscope that the charger has seen that we've connected the car. We've got 9 volts on our positive cycle, so this centre line here, which we can see, in fact I'll find something to point with, that might be easy. So this centre line is our 0 volts, and so we're showing we're actually at 12 volts here. Well, 12 volts would be here, we're actually at 9 volts, and we're going down here to, what does it say, oh, minus 11 volts. So that's showing the normal pulse width of the charger, and it's waiting to see a response from the car, which we can give it by entering the next switch. And you probably heard the sound. That was the charger actually switching on the charge. And what actually happened, well, this top signal got pulled down, so it's now at a much lower voltage, which is our 6 volts, 6.4, and at the same time we're still getting our minus 12 voltage, which it's expecting to see, and it's given us a duty cycle of 53%, and the frequency is 1 kilohertz. So that is basically the full signal telling the car that it can charge and take 32 amps from this charger. And if we come across to the charger, we can see, I don't know if you can tell, but that is a green light which says it's on and it's charging. That is basically the way this charger works. It's a dumb charger, it just charges. Now there are a few things which we can do. If I go to my box, this little switch will actually remove the diode, and the diode is a safety feature, and what its purpose is to do, its purpose is to allow the system to give us this minus 12 volt signal, where we only go a positive 6 volt signal, positive 9 or positive 12, but by putting the diode in, it removes the resistors that the car will put into the circuit to pull this voltage down. And it's just a safety feature to ensure that it's not actually looking at a plug that's been dropped in a bucket of water or something like that. We can test this, and what I'll do now is I'll actually remove the diode from circuit, and we'll see what it will actually do, and see if we can capture this on the scope. And you heard the click, and basically you've seen that the minus 12 volts has now changed, and it's now minus 5. So it's basically the same voltage as the positive part of the pulse width, and that is interpreted as an error because it should not do that. And the charger can't be certain whether that is actually plugged into a car, or whether it's just the fact that the plug is hanging in a bucket of water or something, and it's just getting the values about where they should be. We'll go up to the charger, and you can see the charger has turned the power off. You heard that probably, and it's flashing there red to show that there is a fault. So it has complied with the spec, and it's picked that up as an error and a fault. Coming down again, if I put this switch back in, which basically puts the diode back, we hear the charger. It's happy now to supply. It's switched back on, power going back to the car, and we come back to our sine wave, and it's the normal sine wave we'd expect to see for a healthy system. Okay, we'll stop there a moment, and then we'll set something else up, and we'll do a little demonstration of that. Okay, we're back with our Rolec charger. We're in charging mode. It's indicating green, the contactor is in, and we've got 240 volts coming to the car. Again, we're using my little test set for checking the car. This is simulating the signals from the car. And if we go onto our oscilloscope, as before, we can see the sine wave which we're, well, sorry, not sine wave, the square wave which we're putting out. And here we can see the top is at our 6 volts or 6.4. Our lower part is at minus 12 volts. Our duty cycle is 53%, which is basically the command to charge at 32 amps, and the frequency is flashing 1 kilohertz. So that is our normal signal when the car is charging. Now, if the car detects that there is a problem, or there's a fault, or for some reason the car is not happy, it can send an instruction back to the charger to say, hey, I've got a problem, turn the power off, I've got a fault. And the way it does this is it pulls this top voltage, which is at 6 volts, down to 3 volts. And when that goes down to 3 volts, that's a signal to the charger to disconnect the power and go into a position where it won't be charging the car. Now I will simulate this, and you should see this happen. So I'm just going to drop this down to say that we've got a fault, and you saw the response there, that basically the charger has stopped. It stopped sending the PWM signal. The voltage line is down, and if we look, the voltage is at 3 volts, and this is the car signaling back to the charger to say, hey, stop, I've got a fault. And if we go back to the Rolec charger, I hope you can see that this is now flashing red. It's saying that there is an error, and in this case the error is generated by the car, which it's obviously not happy with. What we can do, again, coming to my switch, I can remove this error, and when I remove the error, what we will see is that we will see that the 12 volts comes back, everything reinitializes, and because we're set up to say yes, the car wants to charge, straight away it's gone back into the normal charge mode, and the Rolec is now providing charging current again. So that is a very sort of quick run through of what we'd normally expect to see the charger doing. Now there's one other check which I'm going to try to do on this charger, and that will be to remove the earth wire and see if the Rolec detects the fact that it's lost the earth. So I'm going to stop at the video at this moment. I shall do that adjustment and then we will try it. Okay, we're coming back to the Rolec charger, and the eagle eye amongst us can see that I've actually removed the earth connection. So we've removed the earth connection, so at the moment this charger is not earthed. This could be the earth connection going to the earth rod, it could be the earth connection going to the household earth system, dependent on your system and how it's wired. But what we are seeing here is the charger is green, the contactor is in, and it is charging the car even though there is no earth on it. So it would appear that this Rolec system, this module here, does not check the integrity of the earth, that there is an earth path, that the system is earthed. So that is one thing that it's not actually doing. Could be potentially dangerous. This means that people are going to probably need to do visual inspections and checks to make sure that the system earth is working. Now, a lot of people may think the fact that you have got this breaker here, which you can test, but you'll notice there is no earth connection on that breaker. So when you actually do a test, you're checking that the breaker will trip with an imbalance of currents flowing in the live and neutral, but it is no way checking that the car metalwork, the charger, is actually earthed. And as you can see, we can press the test and the breaker works and says, yeah, I'm fine, but you can see the earth is removed. So that is okay. That's a bad point against this very cheap charger, but yeah, I expected that, to be honest. Yeah, I can't say any more than that really. I don't know why they didn't incorporate that into the electronics. It should have been relatively easy to do, but there we go. Hey, you pays your money and that's what you get. Okay, we shall move on. Back with you in a moment. Okay, we're back with the Rolec charger. We've reconnected our earth cable, so I'm happy we're earthed again. The test we're going to do now is we're going to see what happens when we interrupt the power, or the power is interrupted when we switch the power on to this device. So we will look at the idea that yes, we can put a contact in the main supply and we can switch the main supply on and off this dumb device to do a time charge. But what we'll do, let's just look at our signals out of this device to see what it actually does while we're doing this, and if we notice anything that might not be quite so nice. We will come down here and we will switch these switches. So we're basically setting it up as though there is a car on the end which will respond and ask for charge. So we've got the scenario that we're plugged into our car and our car is waiting for a signal. As you can see, our signal here is at our 0 volts. This mark's indicating we're at 0 volts. And if we look down the bottom here, it's jumping around a little bit. That's a little bit of noise on the wires. As you see, the voltage is just picking up a little bit of noise as it's trying to find a signal. But yeah, we will do this, and what I'm now going to do quite simply is switch this switch back on. I'll bring you down to look at the scope and let's see what it does. So power's going on. The power is now on. Oh, and we've jumped up to our 6.2 volts. So the car is saying, yes, I'm here and I'm ready to charge. And the system has booted up. It's given the pulse width and straight away it's gone into charge mode and put the power there. Okay, that was interesting. So if we turn the power off using that device, so our car is charging, and we're now going to switch off, what happens? It just collapses. That's it. We see the pulse width decay down very slowly as the capacitor is discharging the power supply, and it stops. Okay, not the end of the world. Let's just make it so that the car is connected but the car is not asking for the charge, so we won't pull it down to the 6 volts, because in the real world that wouldn't happen. The 12 volts would go to the car and there would be a slight delay from the car while it checks everything before it would make that signal. So we're going to do the same again, and we are going to put the power on. We're up to our 12 volt signal there, and our little module is flashing away as it's doing its tests. And if we come back, there we go. It's now putting out the pulse width signal, and you'll notice here we're at 9 volts positive and we're at our minimum 12 volts minus 12. We've got our correct duty cycle telling the car that it can have 32 amps, and we've got our 1 kilohertz frequency. And the response we'd expect to see would be coming from the car of that 6 volts, and hence you heard the charger has responded. So it looks as though that is a feasible method of control on this charger, that we can just basically break the power going into the charger. Yes, that's something we'll explore a little bit further, I think. Looking at this charger, I've a couple of thoughts on it. We see here we've got some very nice thick 6mm cable which is going down our lead, and again the cables coming into this charger will probably be at least 6mm, if not larger. Personally, I like to go 10mm and above, just purely to get rid of volt drop and save a little bit of power that you'd lose in the cables. But the thing which disappoints me is when I look at this interconnecting wire, these interconnecting wires, I mean these are the main current carrying wires which are carrying the current to the car. I'm going to have to check those, but maybe they are 6mm. I will check those later, because I don't know, they look a bit small to me. I would have probably liked a bit thicker, but I'll check the sizes of those later and we'll see what size they actually are. Other than that, we bring our live and a neutral across. There's our neutral, and there's our 240 volts live to feed this module. So I think that could be quite a simple modification on this unit. We only appear to have 240 volts available. We've got 240 volts available here to power anything we do. Don't really want to take this module apart and go inside. I think it's something that we could do, but I don't really think that's the sort of thing that people would want to be doing. So let's look at the easy way that we can do this. Right, just before we do that, we'll go down a little bit, because I do tell people this wire here, this is the pilot line. This is also a wire that we can break. This is the wire that's carrying the 12 volt signal that we see on the oscilloscope. It's 12 volts, it's very low current. but that is also a wire that if we break that wire and with a relay contact and we just switch that wire on and off with some sort of device for timing, yes, we can charge the car with a time schedule. It will wake up the MG car as well, the MG EV. By breaking that wire, it will wake the car up, the same as up here. So yeah, we'll look at that a little bit more.